So hello everyone, welcome to another ML project building series. Today we're gonna be building a wine quality prediction model. Using this model, we're gonna be predicting the wine quality is bad or good. So let's start. So first one, what we are having here, we are having the steps that we're gonna follow to build this model. On the previous videos also, we use the same kind of steps like data import, ED, also known as exploratory data analysis, feature extraction is there, and after that we move on to pre-processing, and after the successful pre-processing, we're gonna be building the model. And after building the model, we're gonna jump into our model comparison. For model comparison, we're gonna be using some relative model algorithm that will gonna predict how much score it is getting. We're gonna be comparing to those other with those other models. So let's jump into our other section. Here we are getting the prediction that will gonna be predict from the data set. So here I wrote here outcome prediction. For if outcome is coming as 1, like our result is coming as 1, it means wine quality is good. But if the outcome is coming as 0, wine quality is bad. So for our data set here, we have different values on our result column, like 4, 5, 6, 7. Like I am telling all those number as random values. For all those random values, we will convert those values into 1 and 0, because we are using here classification algorithm. We'll see this later on our Jupyter notebook. So here I did a ML model breakdown over here. So as I told earlier, I will be using the classification algorithm. For classification, I selected the random forest classification. So what a random forest classification done, for each of the section, it takes a decision tree over here. Like it will take a number of tree. Let's break down a tree over here. So for a tree, we are getting a side as 0 and another side as 1. If it is predicting is as 1, we are getting the wine quality is good. But if it is predicting as 0, it means the wine quality is not good, it's bad. So after that, we have other section also, like the tree is breaking. So all those breakpoints are checking the other parameters like acidity values, pH, and sulfur, the level of sulfur and all the other parameters that are present on our data set. So using this same formation, we are using multiple trees, up to n number of trees, and using that n number of trees, the majority voting or the average or the majority one that we are getting, it will be going to the final step or final class. So after that, what I'm gonna do after model building process, I'm gonna jump into our model comparison. So what I have on the model comparison is that we'll use different type of classification algorithms that we used on our previous videos also, like logistic regression, decision tree, KNN, also known as K nearest neighbors. Also we have support vector machine, XGBoost is there, and gradient boosting machines also are there. All those algorithm we're gonna use, and we're gonna make a comparison, the most highest accuracy ML model that we're gonna use for prediction. So let's start with the model building process. To build this machine learning model, we're gonna be following those steps like data import, EDA, feature extraction, model building, and model comparison. So let's begin. So here on our Jupyter notebook, what we have, we simply imported our libraries that is needed to build this machine learning model, like NumPy, Pandas, Matplotlib, Seaborn, and from sklearn model selection, I simply imported the train test split, and also from sklearn assemble, I imported the random forest classifier. And also coming up here, sklearn.metrics, I simply imported the accuracy score. Later than using this accuracy score, I will gonna measure the accuracy score of the machine learning model that we're gonna be predicting. So after that, what I did, I used data, and I used pd.read underscore csv function to define the data. So let's run it. So over here, what I did, I simply took data.head. On data.head, what we have, we are having the first 5 rows over here. We can also simply do print print the data. So for print the data, other rows are also coming, but it's not in a quite good shape, so we're gonna use that one only, dot head. So here for the columns we have values, we have information like fixed acidity, volatile acidity, critic acid, and some other values like free sulfur dioxide, I think, and total sulfur dioxide, density, pH, sulfates, alcohol, and on the last is quality. So from this whole data set, we're gonna be using quality to predict whatever the quality is of our wine, and all of the rest of the columns that are here, we're gonna be feeding onto our machine learning model to predict this quality column. So what we can do right now, I can simply jump into EDA process, simple EDA process. So for that, I'm gonna check the data shape. So for data shape, what we have 1599 rows over here and 12 columns are there. So after that, what you can simply do, we can check is there any null value or not. So I'm gonna pick data. I'm gonna take is null. When I run is null function, I can see the first five rows and last five rows do not have any null values. All are coming as false, false, false. But I do not know is there any null value lies between those those row that are in between. So what I'm gonna do here, I'm gonna call the sum function. So using the sum function, as you can see, all other columns are visible over here. It is coming as 000 individually. That means there is no null value for all the columns. So what I'm gonna do next, I'm gonna pick the sum again. After calling the sum function, again the total value is coming as 0. It means there is no null value. It is a good thing that there is no null value over here. We know, as we saw on our previous video, if there is any null value, we need to simply drop it. What we can do after dropping it also, we can also do something initialize like any blank format for this null value. And I think as we do not have any null value, we do not need to do anything for this one. After that, what we can check over here, I can call data.info. On the data.info, what we have, all columns are coming over here, and all columns have null values, and most of the data types are coming as float, and only one column like the quality column is coming as the integer values. So for data types, we have two classification. First one is float format and second one is integer format, and the memory usage is 150 kilobyte. And as we saw earlier, we have 1599 entries which are rows, and 12 columns are there. What we can do up here, we can simply call a describe data.describe over here. So using data.describe, we can see some different values are coming like minimum, 25%, 50%, maximum, standard value. And for minimum values, we can see that many columns values are coming are starting from 0.000. Some are starting from different, but some are starting from 00. And what we can do after that, I think the EDA process is enough for this one. We can check our quality data set once. So I'll call quality data. As we are predicting the quality column over here on the machine learning model, we need to check how the quality column is. So what I'm gonna do, I'm gonna use value count underscore counts. When you run the value underscore counts function here, I can see different data that is mostly available on that column are coming. Like we have 5, 6, 7, 4, 8, 3. The 3 value have repeated 10 times, 8 value is repeated 18 times, 4 value 53 times. So what you can do over here, as we are picking a random forest classifier. It's a classifier algorithm, machine learning algorithm. So what we need to do, it is right now in continuous form. We need to convert into some sort of categorical data. Let me write it. We need to convert this into categorical. So to convert this categorical, we need to decide something range between, like we need to convert it between 0 or 0 and 1, which means yes and no, which also means the quality is good or neither the quality is bad. So what you can do up here, I can simply pick up range like 5 or 7 also I can pick, under 7 the values are coming, the quality will be bad, and after that the highest coming after 7 all the values, the quality will be good. So what we can do here, we can simply split the column right now on, and also let's split the column over here, separate the data. So for separating the data, I'll gonna take X and I'll gonna pick data and I'll gonna drop the quality column over here, and I'll gonna use axis as 1 to define the column. So here as you can see, we are dropping this quality column over here. So for the X, all other columns should be initialized. So let's check and run it. So I'm gonna hit print X over here. As we run print X, as you can see, all other columns are coming without the quality column. Our separation is done for X, and let's pick Y over here. Let's just do a one thing, like initialize it to bigger X. That will be okay for us. Let's take it to big Y, and after big Y, let's pick data and pick the quality column only, because for prediction we are predicting the we are predicting the quality values over here. So let's pick up the lambda function, using apply. We're gonna use a lambda function over here, and using this we're gonna use the y value, and for y value, if it is 1, we can pick if, let me write it and I'm gonna describe it later. So let's print it, let's see it's working or not. Yeah, it's converted. Like what I did over here, I simply picked the quality column over here from dataset, and I applied a lambda value. For lambda, what I picked over here for y value, I am giving 1 if the value is coming over if the value is coming over 7, in the range of 7 or over 7, and else if the value is not greater than 7, it will come as 0. If the value is greater than or equal to 7, then it will come as 1. So after that I am printing that. As you can see, all our data is converted. To make sure, what we can do over here, we can use y dot, we can pick value counts here again. Okay, sorry, to pick one. Okay, as you can see, for 0 we have 1382 values over here, and 1 we have 217 values over here. So I think the data separation is successfully done. What we can do after that, we can train, test and split this data. So for train test and data splitting, what we can do over here, simply I can take this one, and what I'll do over here, I'll pick X train, as we did also on our previous videos, X test, and Y train, and also Y test. here I'm gonna use the train test split, and I'm gonna pick X, also Y, and for test size I'm gonna pick 0.2, and for random state we can use for random state we can use 1, 2, or also 3, both all the 1 hour. Let's run it, and after that to check, let's use print, and let's check xtrain dot shape x test sorry test dot shape. As you can see, it is the data set is divided over here. And now what I'll gonna use the model training process. As our data splitting is done, I'm gonna use model building. I'm gonna go through model building process over here. So for this I'm gonna pick model, initialize model as I'm gonna call this one random forest classifier, as we defined over here from sklearn.assemble, as it is a assemble model. So I'm gonna pick over here and simply paste it, and I'm gonna simply run this function. So I think it is running. So let's use the fit function over here, and let's apply it to our x train and y train. I think this is working. So let's jump into our model evaluation to check model is properly working or not. Sorry. And for this step, what you can do over here, you can pick like x something, x test prediction, and for x test prediction let's use model and model dot predict, and using the prediction we're gonna simply use the test over here, as we are predicting on the test on our test data set, as we defined over here x test y test. So after that what we can do over here, we can check accuracy. I'm gonna simply write acc, and for accuracy we can pick this one, our accuracy score from sklearn.metrics. So I'm gonna simply copy it and paste it over here, and for that I'm gonna use x test prediction, and after that what I can do, I can simply run it over the test, and let's print it down. So I'm gonna use let's simply run it over here, initialize acc, which means accuracy. So as you can see, our accuracy is coming a little bit higher, like 0.92%, which is a good range. I think our model building process is done. What we can do next, we can build a predictive system over here. The reason we are building the predictive system, that we will check our the data is actually our predictive system is properly working or not. Let's do some prediction, like building a predicting system. So what we can do over here, I'll just pick the file over here and simply search for it. Yeah, it's coming over here. So this is the data CSV file over here. We'll simply copy these values without the quality column and check is there it's working or not. First I'll convert all those into a numpy array format, then I need to check over here. So what you can do over here, you can use input data, and for input data I simply leave it as blank, and I simply use the input data as numpy array. I'm gonna use here np as array function, and I'm gonna simply use the input data over here as we are converting the input data into our numpy array. So what we can do after that, we have to reshape our data over here, reshape the data over here, and simply I'm gonna take input, sorry, input data reshape. For input data reshape, what we can choose over here, we simply use this one, our array numpy array, and for numpy array we'll reshape it, and for reshaping I'm gonna use 1 and minus. Okay, after that what I'm gonna jump into our prediction. So for prediction I'm gonna use model dot predict, sorry, and for using the model dot predict function I'm gonna feed the input data reshaped over here. So after that what we can do over here, we can print our prediction. So I think it's done. So what we can do here, we simply pick this one. As it is below 7, it should come as 0. The prediction should come as 0. So let's pick it and simply paste over here and run it. Okay, it is coming as 0. It means the wine, the quality of wine is not good. So let's do a thing. I can use if else condition and use a prediction over here. I'm gonna initialize it as 1. If it is as 1, I'm gonna print the wine quality is good. And else what I can do over here, I can simply tell the wine quality is not good. Wine quality, I can also say it is bad. Quality is bad. Okay, so I think it's working. Yeah, it is coming. The wine quality is bad. So up to now our model building process is done, and also our predicting system is perfectly predicting our values and giving us a prediction that the wine quality is good or bad. So I think up to now everything is successfully done over here. Now what we can do over here after model building and using the predicting system, we can jump onto our model comparison. Here I'm gonna use some models that fits on classification dataset that will gonna help us to compare the other models with the current model, and we can use the highest accuracy model one to predict this system. So let's do it. So let's jump into our Jupyter notebook again. So here what I did, I simply pasted a piece of code that I previously built. So on others the video also I did the same thing. So here I imported all the libraries again, and after that I splitted the data set. What is optional is needed also, you can do, also you can not do. And after that for model I am calling all the models like logistic regression, decision tree classifier, random forest. All these models are based on classifier only, and the last two are from boosting technique like gradient boosting classifier and add boost. And after that what I am doing, I am taking blank score, and for all those score that I am getting over the accuracy score, I am initializing all the score into this scores one, this blank score. After that for model comparison I am using a bar plot, plt dot bar, and inside that I am initializing the scores that I am getting over here, and score dot keys function I am using. And for colors I am using some random colors like blue, green, orange. And for X label, Y label and title name is there. And after that, for what I am doing, I took a for loop. I used a for loop over here. And for each of the bar plot bar, I am using the accuracy number over here like this: 0.87, 0.90. It should be shown. And on the last I used plt dot show. And after that, this one came: comparison of an ml model, ml algorithm performance. So here, as you can see, we are getting the highest accuracy from this chart. That is random forest, like nearby it's 0.90, which is 90% also. And after that, we are getting decision tree as 0.87%, which is 87% also. The minimum that we are getting, I think this one ADA boost 0.84, 84%. If we compare all those onto the previous one, like this one, what we did over here, random forest classifier, we are getting the highest score as the random forest classifier. What is that is 0.92%. And using this model, I predicted the wine quality is bad or good. So I think that's it. Our model building and model comparison is done over here. So for now, today, everything is done. Thank you for being for such a long time.